Welcome back to Cap That Flag. Today we're continuing our picoCTF series with a challenge titled Tunnel Vision. It's worth 40 points. It's from picoCTF 2021 and it's in the forensics category. The description reads, we found this file, recover the flag. So let's start by downloading the file using wget. Then we'll use the file command to have a look at what sort of file this is. And it's just returning that it's data, which isn't particularly helpful. Let's use trd instead, which is kind of like file, but it gives a more accurate result sometimes. And so this is saying that it's a Windows bitmap file. So let's use xxd to look at the hex of the start of the file. We can see the magic bytes at the start of the file are a BM, which is standard for a bitmap. So it does look like this is potentially an image. So let's try opening the file in an image viewer. And so the file won't actually open in an image viewer, so there's potentially something wrong with the file. So next I'm going to use WX hex editor to look at this file. And so this is a hex editing application that's going to let me change parts of the header if there's issues. But what I'm going to do is I'm going to go through the documentation for a bitmap file and what the header is supposed to look like, and I'll compare that with the values that we have in the file and look for anything that's out of place or that seems incorrect or corrupted, and then we'll try and fix that up. So I'm going to tag some zones just to make it easier to see, and I'll do that and then I'll jump back when it's finished. Okay, so I've got the tunnel vision file open in the WX hex editor now, and I've tagged the header fields with what they represent in the header for a bitmap file, and we should be able to go through each one and just check that it looks correct, because there could be something here that is causing the file to essentially be corrupted and not to open properly. So I've got the information about the file format just from Wikipedia over on the right hand side, and so there's basically two header parts to a bitmap file. There can be some other optional ones, but the mandatory headers are this first one here. When you've got, needs to start with a B and an M for Windows, and then you've got the file size in bytes, and so this is going to be a little endian stored number. So if we go over to a converter here, so 2C268E, convert that. So the file size is 2893454 bytes in decimal, and if we check that against here, 2893454 for the file, so that looks correct. That's all looking good so far. Then if we go back to the file format, the next two are reserved. It says can be set by the application, but can be 0 if the file is created manually, so it doesn't seem to really matter what these are here. And this next one is, and it's the last one of this particular header, is the offset, i.e. starting address of the byte where the bitmap image data pixel array can be found. So after these headers is the start of the pixel array, and this number here should be the address of that byte in the files. And again, this is little endian format. If I convert this, it's saying the pixel array starts 53,434 bytes into the file, which doesn't seem to be correct to start with. So we're going to rewrite the value in this pixel array address with the value, the address of this byte here, which is at cursor offset 54. So if we start by zeroing out this part, and we want to set the BA to be 54. And so 54 converts to this binary number, so it'll be 00 and that. So we'll edit this BA to be 001010. Let's turn that into 36 in hex, which is equal to 54 in decimal. So that's now been set to the correct value. Now, if we keep going, we then get into the next header, which is called the dib header. And this very first field is the dib header size. And if we go back to the file format, I'll scroll down. Here we go. So this is the size of this header in bytes, and it's always 40. It's always 40 bytes long, this particular header. So this number here is a lot bigger than 40. I think we looked at it before. It was like 54,000 or something like that. 53,434. We instead want 40. So we'll convert this straight to binary, and then we'll zero out this one. And then replace this one with 1, 2, 1, 0, 1, 3. So now that's 28 in hex, which converts to 40 in decimal. And then I'm going to save it. Then we can try and open the file again with our image viewer. And we do open the image, although we don't get an actual flag. Get not a flag, sorry. So let's use EXIF tool to have a look at the metadata for this file. So now I want to have a look at the size of the file, as well as the width and the height and the bit depth of the image, to see if they all make sense together or if there's potentially something going on there. So I'm going to use a calculator, and if we have 1134 times by 306 times by 3, because there's 24 bits per pixel, that gives us just over 1 million bytes, or 1 megabyte. But the image length is almost 3 megabytes. So if I take the size of the file and I divide it by 1134 and then divide that by 3, we'd expect the height of the image to be roughly 850 instead of 306. It's also possible that the width could be a lot longer and it stays the same height, but let's try this way first. So back at the hex editor, there is a part of the header field that looks at the horizontal and vertical size of the image, and that is just here for width and here for height. And so this would be 0132, which if we go back to the converter, putting 132 into the converter gives us 306, which is this exact same number as the image height, which is what we expect. So we want to try and increase this number in the header to see if we get more image revealed. I'm currently kind of guessing what I want the size of the height to be for this to make sense. And I feel like if I get it wrong and go too far, then the image won't open. So I'm going to try a bit less than 850. So we'll try 840. And as a hex number, it's 348. So to turn that into the Lendian, I need the first byte to be 48 and the second byte to be 03. So that's essentially been now changed from 306 to 840. So what I'm going to do is save that again. And then let's try opening the image again. Because we've changed that header to set the vertical height of the image to be a lot bigger, we're now seeing more of the image and we can see the real flag at the top. I think this is the first challenge where we've needed to use a hex editor, which has been interesting. But anyway, that wraps things up for this video. Thank you for watching, and I'll see you in the next one.